So, yeah. Hi again, everyone. I will get started. So, uh, as we said, Norman is the interviewer, and uh, I'll make my usual statement that I'm not sure what I'm going to do with the recording, so I'm just requesting permission to do whatever I want with it. Um, to briefly refresh where we were from last time, we have so far looked at two different proofs of tiling for UDT. The first one was a proof of tiling for UDT 1.1, which felt very dissatisfying because it's not Vingian tiling at all. So we really want this idea of um, a single agent tiling, but without knowing its other self's actions in complete detail, because it seems unrealistic for AI to be able to get self-trust just by knowing everything that it will actually do in the world. And then the second tiling proof that we considered addressed that issue by moving to UDT 1.0, but in order to get UDT 1.0 to tile, we need to somehow rule out coordination problems. And the way that we did that ended up playing such a large role in the proof that I would call it basically assuming the whole thing that we want to prove, almost, like uh, we just basically the fairness assumption just sets us up to the point where we can apply coordination and then just prove the whole thing we want, right? And so this is dissatisfying because we uh, um yeah. Hi, Mateusz. I was just reviewing where we were. um so yeah, this proof seems dissatisfying because it is basically just using the coordination assumption, which is some kind of statement that the agent does take the optimal action. And so even though it's more Vingian, it is just proving it from one of our assumptions, and we really want a more detailed look at why the agent trusts itself, how the agent can trust itself. So this next tiling proof that I'm going to go over, the idea is to show the agent doing at least some reasoning about what its decision procedure is and achieving tiling from that. Uh, so we're going to make a much more restricted coordination assumption. Instead of the coordination assumption over here, which is like, um, if the expected utility of a policy is better than the expected utility of the policy actually taken, then moving to individual actions of that other policy had better be an improvement. So this is like saying we're not at some local maxima that we can't escape by taking individual steps. Here, what I'm saying is that if I'm argmaxing on the expected utility of an action at a particular observation, then it should be the same as argmaxing knowing some extra information about my policy. So in other words, it doesn't matter, like knowing what the agent does in other observations doesn't matter here. Roman?
Yeah, I wanted to say like in other words, it's restricted in the sense that before we needed to know about this fact about the whole policy, and now we needed to know, like we restricted it to just 2 policy points.
Yeah.
If that makes sense.
Let's see. So
Well, there is an inequality, and there is yeah, it's a bit different. Okay, I will reformulate and say it again.
yeah, it is a bit different. It would be maybe nice if this was an inequality instead of an equality. I wonder if I checked whether that would work, but yeah, I guess maybe restricted coordination isn't the best name because it's not just like some direct restriction of the previous coordination assumption. I called it restricted coordination mostly because I had the intuition that it was less powerful. Mateusz?
Yes, I was thinking, like, couldn't you just, like, you need to talk about probabilities here, or could you just say that for all pairs of observations, this is the case, or like is the probability here the subjective probability of the agent?
Yeah, definitely.
Okay.
It is the prior probability. Agent knows
Okay.
it before everything happened to the agent.
Yeah, but yeah. Yeah, I mean, I see the contrast because previously in the previous proof, I think in the previous 2 proofs, you weren't talking about probability. You're just like making a logical statement.
It's implicitly in the probability, like it's expected.
Okay.
It's expected value under the prior, so it's
Okay.
about
Okay.
probability.
Okay.
Right. So yeah, every time there's an expectation symbol,
Right.
I could have done the subscript saying it's occurring to the prior. This is like doubly nesting. Like we have a subjective statement inside of a subjective statement, which, yeah, my previous things haven't done. So yeah, that's the coordination assumption I'm making this time. Then we have limited self-modification. So I'm assuming that the self-modifying actions are now allowed to only modify one other policy point. So this is a pretty significant restriction. I don't think that it has to be that severe, but this is the version I could get to work, mainly because it gives me like easy notation. I can just refer to the action, the observation and the action that's being modified. And so it made things easier to write out. I did make an attempt to generalize it somewhat last week, but I ended up deciding against that for the paper I'm revising because I still haven't gotten word on exactly when the revision deadline is, and I decided it was going to be more work than I wanted to do to try to propagate the notation throughout everything. So yeah, I think this one we can probably lift the restriction at least somewhat, but I'm not exactly sure how much we can generalize it. And then fine-grained fairness. So the idea here is that the expected utility of a self-modifying policy point is equal to, remember I gave that definition of when we run a self-modification, we substitute the particular self-modification for its corresponding non-self-modifying version of that action. And then we substitute the individual policy points that it says to substitute. So this is saying basically that when we do that run action, it doesn't change the expected utility. Whereas previously I was saying like, well, the effective, go all the way to the effective policy. So now we're like looking at individual steps instead of going all the way. And then we have faith and argmax. This is the trickier one here. I failed to correct it. So this should be pi star of O equals argmax here.
Not pi star. Why pi star?
Say again?
Why pi star? Like why not? So it's
Oh,
not pi star.
You're right. You're right. Yeah, you're right. And so what this is trying to say is like the expected utility when we consider argmaxing should be the same as the expected utility. Should be at least as good as the max that we could get with the individual argmax, or like, yeah, the max that we get considering the individual actions that we're argmaxing over.
What is phi here?
So phi is just like some extra condition.
Okay.
So I'm saying like this should also be true. It's like a way of strengthening it, the statement further. Saying like we expect this to be true even in the presence of some kind of distractor sentence.
Right.
I just thought about something like, what if this phi is something like argmax is equal to some other action? So argmax is evaluated to be some another action. So it's like contradictive. This is like, what about like this contradictive statements?
Yeah, that's a good point.
I mean, my thought would be that you want to restrict the set of propositions that you are considering. That's the most obvious patch.
Yeah.
So not for every phi, not for every phi.
Yeah, it would be good to figure out what phi. I mean, so we can look at the proof and think about what phi we actually need.
Sorry, I don't understand.
Okay, yeah.
In our base.
Yeah.
So, sorry. Like why is like the argmax in the left hand side a statement, like what does it mean to condition on that?
I wish I could write on the slides in this format.
Should be pi star equals argmax, right? Pi star equals max.
So that's
not
what I
pi star equals max.
And then Roman is like, well, so I just have pi here. So it should, to match, it should be pi equals argmax, like pi of the observation equals
argmax of that.
Maybe I want to put a star on all of these pies though.
It's probably like better to not, like, because it is the pi star is what like the UDT evaluates, right?
Right.
Okay.
And so this tries to make it more general by just saying like any pi.
Okay.
So yeah, it should be like it should kind of match the form here, right? Like we're trying to say like we have this kind of recursive form where this mirrors this, but A becomes that argmax expression. That's what's important here. Did I see a hand or?
I mean, I raised a hand, but I'm not sure. Well, I thought that maybe you could also patch the problem with contradictory propositions by like making a distinction between like believing a proposition and kind of observing a proposition in a sense. But I'm not sure exactly how this would work. But that sounds like somewhat in the spirit of radical probabilism.
Believing versus observing.
Well, the UDT in some sense doesn't actually believe anything besides its prior. Like it doesn't actually update its own beliefs. So
strict UDT does not, but like I think this is to some extent like in the spirit of open mind, of like opening up UDT.
But how would it help?
Hmm?
But how does it help? Like how would?
I mean, if you only observe, you mean the idea about observing a proposition?
Yeah,
Or,
like how would it help patch the problem?
I mean, you no longer have a contradiction. You only have like there's a kind of separation between like you have some evidence for the contradiction because you observe that you observe that this statement is true, at least according to maybe I don't know your internal computation or some external source, but you can kind of choose not to believe in it. You have some degrees of freedom. I mean, that's like a very vague idea.
Yeah, I mean, it's like it causes the same problem if you do believe in that connection. So it seems like a fragile thing in that respect. Because you're not saying, well, you're outright wrong to believe in that connection. You're just saying, well, you might not. And also, I would disagree that it's in the spirit of radical probabilism.
Okay.
I think that the Bayesian perspective on filtered evidence is that we can always solve that problem by wrapping our observations in some kind of statement that says, I observed this, rather than just conditioning on X. You condition on like, I observed X, right? But radical probabilism doesn't like the idea of these special observations as much. Like, well, yeah, that's a big topic. It's like ordinary Bayesianism, in addition to the Kolmogorov axioms, like the Kolmogorov axioms are like the official law of the land, plus Bayesian updating, of course. But then there's a sort of a deep state of like the evidence partition assumption, which is the assumption that there are these special like evidence events or observation events, which are different from other events. And I call it a deep state because it's like assumed in most Bayesian contexts. Like information theory makes this assumption, Solomonoff induction makes this assumption, lots of particular Bayesian theories make this assumption. And yeah, radical probabilism questions this assumption. So anyway, that's a tangent. So let's go back to, do we fully understand the idea behind faith in argmax yet?
I was actually going to say the comment about potentially self-defeating propositions phi reminds me a little bit of actually two of the other problems we've grappled with on the one-on-ones.
Yep.
Both the thing about the Gödel coins and the thing about can't remember the other one off the cuff. I mean, I guess to an extent, it rhymes a little bit with the problems of the 5 intent problem, but not quite. Things about trying to update on things that care about what you've updated on, or how
Yeah.
you've updated on them.
Yeah. So basically, I've been using this trick of adding this phi in as an extra condition. And it's a tricky trick. It's a dangerous trick because if phi can be anything, then it doesn't necessarily make sense to assume whatever I'm assuming, given arbitrary phi.
Yeah, because just off the dome, you're sometimes going to be forcing your expectations to be conditioned on probability 0 events.
Right.
Like
Yeah,
the proposition that phi of 0, like the proposition that pi of O is B, which otherwise looks totally innocuous.
Yeah. Amongst other possible bad things I could condition on. So
it doesn't seem like faith in argmax actually quite holds up as written.
right, yeah, I'm agreeing with that.
While I still have the floor, while we're still like only halfway through this in our group session, I feel like I should bring up that there's a call for papers to that conference at CMU, and the deadline is in a little under 2 weeks. Do we want to try and get something to that or no?
Oh, that's a good question. Yeah, I'm still working on this paper, which is already submitted to a different place. The call for papers does say that you can submit multiple places, but I talked to one of the organizers, so I'm not gonna submit this, but it would make a lot of sense if you guys thought that you could get something together in that amount of time and we're interested.
That's gonna be a little bit difficult.
Right. Yeah, I think it's like, it's not obvious to me that any of you guys' research is to the point where it would make sense to try to get a paper together in that amount of time.
Yeah, and I would have, if anything, expected that if we were submitting a paper to this, I mean, even it didn't actually have a ton of lead time. I would have expected if we were submitting a paper to this, it would in fact be some part of your, I mean, as a scaffold, some chunk of your notes, maybe some of the stuff that you hadn't put in that paper, and then whatever work we do to add on to that. But are you submitting like a whole thing that includes all of these things that look kind of sketched out at the moment?
So yeah, I'm not submitting anything to the CMU conference. The thing that is under review in a different venue is the draft paper that I've been discussing with you guys that this presentation is like basically about. So,
And you spoke with the organizers of the CMU conference, and they told you that you shouldn't submit that paper that you'd submitted elsewhere, or even any part of it.
right, yeah.
Did they give you a reason, or?
I mean, it's from my perspective, like from my experience, it's pretty unusual for conferences and journals to be open to submissions that are being submitted elsewhere at all. And so I was surprised when they said that they're open to that. And so when I asked him about it, I was like, is the intention that I should submit this paper that's already under review somewhere else? Then the organizer I spoke with was just like, well, if you want to give a talk on it, there'll be an opportunity for that. There's no reason to additionally submit it. And so, yeah, that's what I know.
That's really weird. I'm gonna go with that's really weird overall. To both, on the one hand, say yes, please, totally submit paper stuff that you're early in review in other places, or that are just drafts at the moment, or that you maybe send out to other conferences. And then when you go and actually talk with them, they say, actually, just kidding. We don't want you to submit that paper because it'd be weird if you submitted something to more than one place.
Yeah, and then I said, well, I was just kind of confused why you made this request in your call for papers, and he just changed the subject. So anyway, yeah, okay.
That's something feels off with that. Then
maybe that's enough on this aside, though. So we're comfortable with faith in argmax to the extent that I'm comfortable with it, I guess.
Sure.
And then additionally, we're explicitly making the assumption for this one that the agent does know its own decision procedure. So, like I said, according to Wei Dai, all of these should be making that assumption because according to Wei Dai, pi star is just like the decision procedure of the agent. But I specifically need to make that assumption in this particular case.
Can I
Yeah.
ask about fine grained fairness?
Yeah.
So the question is suppose that the self-modification self-modifying policy modifies the policy point that the modifying action modifies is that it's itself.
Okay.
So I think limited self-modification doesn't rule out this case. then wouldn't the conditions, the two conditions on the right hand side be in contradiction with each other?
Ah, yeah.
Because observation might be O, like observation of AM is equal to O. That it's only the only case that they might contradict each other. And
Yeah.
I guess it is. It might be implicitly restricted in the assumption about like the causal, like the rolled out policy, like Like a few slides back, when we assumed that action cannot modify itself, like policy point cannot modify itself, something like that. It should always in the causality of like our timeline should be always after, like otherwise the problem setting is wrong. So
I think that's what I was thinking when I wrote it, but I think that I think that's the right way to think about it, but the way that I've made those assumptions doesn't make that completely clear. Like when I wrote the causality condition, yeah, the assumption that I explicitly wrote out is that there is a well-defined limit of running the self-modification. And this does not explicitly rule out a point modifying itself. So I do need to additionally make that clear somehow. So I'm going to write that down.
So I don't fully understand Roman's justification for like a policy point modifying itself doesn't make sense. But I guess my own understanding is that it doesn't make sense because like it isn't like why would the self-modifying policy want to define it this way? It doesn't seem to be useful. So sorry, this is is that the same kind of intuition that Roman is saying?
No, I don't think so. I think it's more about causality. So I've kind of stated that the like which policy points are allowed to modify which other policy points is under some kind of causal constraint, right? That like we can't time travel, we can't get out of bed and then self-modify ourselves to have never gotten out of bed. And so this is very similar to that we can't self-modify ourselves to not currently be self-modifying ourselves. That doesn't make sense. But the way that I've written my causality assumption, because I wanted to steer clear of actual causality, it doesn't make that restriction.
Okay, so it's like self-modifying for the future. You could self-modify for something that you should do now.
Yeah. Any more questions?
I have a question about restricted coordination.
Cool.
So does it mean that I even if so if O2 is in the future, if O2 is in the future of O1, then it means that I can't expect myself to do something in the future, and
Yep.
Okay.
So yeah, it is quite severe.
Okay.
Like if I like say we're ruling out coordination problems in a way that rules out like if I'm crossing the street, I need to know that I'm not going to just swerve off the crosswalk and run into traffic. Like this is a type of coordination problem. In order to begin crossing the street, I need to trust my later self to not do that. And we're ruling out problems of that kind.
Wait,
You're saying that the prior handles that? Is that the intuition?
Yeah.
Like any kind of the scenarios that you that you would expect you need to know your future self to will be doing something that's already included in the prior. So this is also like some
So we're conditioning here, right? So it's not just, I'm not just saying we trust our future self to not run into traffic. Like, it's not just that we can walk on the sidewalk because we trust our future self to not run into traffic. It's furthermore saying, like, even if we condition on running into traffic, in addition to conditioning on starting walking down the sidewalk, then the expected utility is exactly the same. And so it's really better thought of as ruling out decision problems where that's the case at all, as instead of saying, if you're in such decision problems, then your prior on your own actions has to be such that you're not worried about it. So I would say it's like quite a strong assumption, and we would like to make a much weaker assumption instead if we could.
I'm not sure that the more I think about it, the less sure I am that restricted coordination holds up. Because what that seems to me to be saying is the probability that your expected value, if in situation 1 you do A1, and in situation A2 you do A2, in situation 2 you do A2, the probability that your payoff, the probability that your expected,
Not the payoff.
the action
Argmax, the action. The
probability
maximum
that the action that you take that maximizes that payoff
Oh yeah,
should
right.
be the same as if you don't know anything about what you do in situation 2 at all. And that doesn't seem true. I'm just thinking about things like the 5-10 problem here now, or like, sorry, the reverse 5-10 problem here now, where it should actually be the case that what you do when you see green room should have some effect on what you think the argmaxing action is to do, given that you've seen red room. Because this is claiming that the argmax for see red room do X and see green room do Y should be different from argmax for just plain what do I do if I see red room.
So first I want to highlight what Roman said. That
Yes.
Yeah, earlier I made the mistake of saying the expected utility is exactly the same. Obviously,
no, it's
that's not
the
what I
moves.
was.
It's the moves.
that
It's not the
action is
yeah.
same.
It's the
So
argument.
that is weaker, but it is still very strong. So yeah, I'm ruling out decision problems like that. I'm not like dealing with them somehow. I'm saying like, no, we're in a decision problem, by which I mean a subjective situation that we think we're in, where the actions don't matter to each other that much. So this is a way of saying there's no coordination problem.
Okay, so we're specifically passing into the case where what you counterfactually do does not matter. Is that right?
Yeah, exactly. Okay. And so there are some decision problems that have this feature. We can just have like a number of isolated different observations with like there's non-trivial decision problems in deciding what action to take, but all of these different observations, they don't affect each other. Roman?
By the way, when we talk about like the probability of that is equals to 1, it is like, it is not the same as like just stating that argmaxes are equal, because
No.
like it might be the case that argmaxes are actually equal, but the agent doesn't believe it. And it might be the case that agent believes that argmaxes are equal, but they aren't actually equal. So
Yeah.
it's completely, not completely, but really disentangled, and seems like anti-epistemology. Like
Wait,
we need
so
to
do we see this
for
condition
agent.
for all O1 or for all O1 here?
Yeah.
Okay, so then yeah, it's a statement about almost sure equality then, right?
But from the subjective perspective of the agent, not in
Yes.
some objective sense.
Yes.
I'm not sure I completely understood Roman's final point. You were saying it's anti-epistemology?
I'm saying is that like we probably should have like the prior is probability is equal to 1 when this is true, when the statement inside of the probability inside of the brackets are true. So I don't know. So sorry.
I don't think it should be when this is true, because then that probably weakens it so much that I can't get the use out of it for the proof that I need. And then if I say, and this is true, like, and the statement inside the probability statement is true, then it strengthens it beyond what I need to assume.
Yeah, I understand. Sorry for interruption.
No, I mean, I'm happy to discuss confusions and such.
I want to backtrack a bit about like I think the last conclusion Abram made was that this assumption constrains us to the decision problems that where you don't care about what you counterfactually do. But I'm not sure if there's like a subtle difference specifically for like pi star being the optimal policy outputted by UDT 1.0. So it's like this condition, extra condition is like it's saying that the optimal action to do in this case is A2. So it's not like you could condition on and
you absolutely
I guess
can condition on that, because the agent, the prior doesn't know which actions are the optimal ones. It's like has some distribution over policies and the policy points, and it's like doing in quote unquote Bayesian update on the fact that considers that this policy point looks like that. Does it make sense? Does it answer your question? Sorry.
So yes, I think so. I could condition on the optimal policy being anything.
Right.
That's what
you can consider any actions here.
We discussed it in the previous session, like that.
Yes, I know. Yeah.
It is like the difference in philosophy. Like there is a philosophy, like by Wei Dai, you said that like we conditioning that this mass outputs this like stuff, like FDT, like functional decision theory. And there is like sense like consider we have some probability distribution, and like we are considering what if. Oh, sorry. I understood that this is the same thing. Sorry. Like what agent actually takes? Like we are considering like what mass outputs and what agent actually takes. This is similar, but maybe not the same. Like, are you counterfactual? What are the counterfactuals? Like, is mass different, or am I doing some other thing? Maybe that's the difference. Do I understand the difference correctly?
So for my part, I don't think I understood Norman's question yet. It seemed like maybe Roman was giving a good response to it, but I'm unclear on where Norman is at right now.
Okay. Yeah, I'm still not sure about everything. So like, if we reconsider the example you gave about like the O2 and A2 being like what you would do when you cross the road, like whether you would swerve
Whether
or
you-
something.
Right. Yeah. I
So
think
I
maybe
was
a better example is like I'm walking on the sidewalk, or like O1 is like start walking down the sidewalk, or like O1 equals A1 is like start walking down the sidewalk, and then O2 equals A2 is like swerve into traffic at some point. And so if I think that I'm going to swerve into traffic at some point, then starting walking down the sidewalk would be a bad idea. Make sense?
But
so I was thinking that since it's pi star, shouldn't it be like, if you think that swerving into traffic is optimal, then you shouldn't walk on the sidewalk. But like so I'm just thinking like, why would you have like swerving into sidewalk is optimal?
Yep. I agree with that interpretation. And what I want to say about it is that so something that I'm not highlighting here, but is sort of going on in all of this, is that in order for UDT to make decisions at all, according to the UDT formula for making decisions, these conditional probabilities need to be defined, which means that we need to have some probability mass on all of the options. That is to say, we need to not already be certain about what the optimal action or policy is. And so we might have like a high probability on some and a low probability on others, but we have to have some probability on all of them in order to be able to condition on them. And so that's why we're open to the possibility that swerving into traffic is a good idea.
Because specifically about O1 and O2 here, right? So this is something like if your UDT agent's policy would, on seeing a normal sidewalk, decide to just walk down it, and also on seeing the sidewalk is on fire, would instead swerve into the road, that the argmax over assuming those two things should be the same for the argmax where you just assume that it sees a normal sidewalk and will thus just walk normally down the sidewalk.
Yeah.
Okay. Or will almost surely have to take the same action here.
I'm also thinking along the same lines. Like, if you believe your optimal policy outputs this action, then adding it wouldn't affect the argmax for the other action.
Yeah.
But I think, like, in my mind it makes more sense than you guys seem to make it out to be. So that's why I'm continuing questioning. But I think I still didn't get it formally. I just have this intuition that if you already if you like conditioning on that being optimal, then it shouldn't affect the other action. It seems sensible.
It seems sensible, but I think it does rule out decision problems that require a lot of coordination.
Yeah,
Like-
Or making the prior in such a way that it deals with all those coordination problems.
Yeah, when I say decision problems, I mean like it rules out the prior representing those decision problems well. Like it rules out the agent knowing that it is in this decision problem.
Well, like with the example with the red and green room, it can be solved if the agent has a good prior, and it's also like this, like with the sidewalk and the traffic, this also can be probably solved if the agent has good enough prior. Like it knows that it will never do the obviously dumb things, so conditioning on that will not result in any changing. Like okay, sorry.
Yeah.
But by Abram's previous comment, you couldn't like know for sure that you're not going to do any of the dumb things. Like
UDT can solve these problems if it just knows with high probability that it won't do the dumb things. That is good enough. But this proof does not represent that fact. Like this proof is ruling out such cases rather than representing the fact that we can solve such cases with the right prior.
Okay, yeah.
oh,
thank
I
you.
see. I see. That's clear.
But like the previous proof was like closer to this, to representing these cases, but it does it in a way that assumes too much for the proof to feel significant. So yeah, it's unclear like how exactly we want to deal with this all properly and get a nice tiling proof out of it. And that has to do with these issues around like the limitations of UDT 1.0. Yeah, shall I move on to the proof? So again, we suppose for the sake of contradiction that the agent strictly does prefer to self-modify in some observation. By fine-grained fairness, we can unpack this self-modifying policy point, making it non-self-modifying.
Sorry, but in the first step. But,
Okay.
So why aren't the two observations the same, or so? I thought the assumption would be that if seeing the same observation, the agent does a self-modifying action versus it does a non-self-modifying action.
Oh yeah, this looks like a mistake.
I just want to know what OM is here.
Yeah, I think my intention was OM is the observation at which we do AM, but I forgot to write the M here. Right, I think I should have written a subscript M here, and that's the mistake.
Okay, that makes sense.
So I'll note that down so I don't forget.
But then you will have to write that M for in all the subsequent. That seems like a right.
I didn't hear anything Norman said.
I think that's huh. Can you hear Norman now? Norman, say something.
Oh,
No, this
sorry.
is problems with my connection. Sorry.
Oh, I see. Okay.
Oh,
So
so it's not.
yeah,
mine.
no.
Okay.
So Norman is just saying that then we have to write the im like everywhere to carry it through. I think that's correct. Yeah. So I might do better just to not have the im, but I mean, yeah, it reminds us that this is the specific observation under which the agent wants to self-modify. Okay, so then, yeah, step number 2, we apply fine-grained fairness to unpack the self-modification into its constituent parts. And then number 3, we're like, well, by definition of max, we should be doing at least as well by just taking the optimal action where we were going to self-modify instead of the action dictated by the self-modification. And then step number 4, we, instead of actually taking the max, by faith in argmax, we should be at least as happy to just know abstractly that we are taking the argmax there. Now this is where we see what phi we actually need, right? So we were saying that this phi shouldn't just be anything, and indeed what we're actually doing is setting the phi to be other policy points. And that's again by another clarification that you guys mentioned of like limited self-modification needs to also stipulate that we're modifying some other policy point instead of modifying the same policy point. So yeah, I think it works to stipulate that phi is some other part of the policy. Mateusz?
So in step 4, you have A without subscript. So I'm assuming that this is the same A that you like. I mean, the result of argmax in expression in step 3. Okay. Oh, right.
It should be the quotes, like the quasi quotes.
Yeah.
Never mind. I was confused.
Yeah. I've been loose with quasi quotes here. You see, there's no quasi quotes on the page when there should be a lot of them, or there should be some of them anyway. But yeah, I'm binding the A to this argmax here is the answer to Mateusz's question. So yeah, so then we've converted this max into an argmax, saying that we should be happy to know just abstractly that we're argmaxing. And then we're applying restricted coordination to simplify the expression in the argmax, saying, well, I've got 2 different policy points here, but restricted coordination says I don't need to know about this other one. So I can consider only the thing that I'm argmaxing on. Consider only the policy point that I'm argmaxing with respect to. And then that gets us in a form where I'm like, well, I'm saying that we should be happy to know just abstractly that we're argmaxing, but I've already assumed that we do know abstractly that we're argmaxing, right? Because we know our decision procedure. This is just our decision procedure. And so that lets us remove this whole conjunct from the expectation, and it should be the same because we already know that fact. And so then we have just the expectation of taking the non-self-modifying equivalent of our self-modifying action is at least as good as the expectation of taking the self-modifying version. And so that contradicts with number one.
All right, so to make sure I followed, step one, suppose for contradiction that there is that for our agent pi star, there is some observation O that will cause it to strictly prefer the self-modifying action AM to the non-self-modifying action A. By fine-grained fairness, the expected value for taking action A sub M on seeing O should be exactly the same as if it were to take the action that AM prescribes on seeing O, and then forever after, whenever it sees one of the things that AM would have had it modify, would have changed
Not
its
one of the
behavior on.
things. It's only one policy point.
Right.
Yeah.
When it sees the one observation that AM wanted it to take a different action for, it takes that action. In
Yeah.
that case, the two expected values should be the same.
Yep.
Now, by definition of max, this is at most the maximum over A of all that stuff on the right side, because it's a maximum over A, where A has now replaced the one thing that AM wants you to do.
Yep.
Now, by faith in argmax, we know that if we replace the max A and A that are bound in 3 with actually we're going to take the argmax over A of things that, I mean, this is going to be kind of tangled, where the one action that you would be replacing, the one action that you would be replacing in favor of what AM would have you do, instead of doing that thing, we're just going to take the argmax over all things, over all actions. Yeah, the argmax over actions we could be taking here, other than / including the action that AM wants us to take. Right? Rather than doing the prescribed action, we're just going to look for whatever the best action is there, just locally.
Yep.
Then by 5, restricted coordination, we can actually drop one of the conditions in that argmax because it's irrelevant here.
Yeah.
We're only caring about the one situation where we see the one thing that AM wakes up for. Then by knowledge of decision procedure, we still know that this is irrelevant because we're actually only caring about seeing O here.
The way that I would put that final step is we know that it's irrelevant because we already know that about ourselves. Like this thing that we're conditioning on is just what we already know that we are doing at every policy point, namely optimizing the expected utility of the action in that policy point. Just the definition of UDT 1.0.
It's kind of like Markov. Sorry. Like it can be written out like P of some fact, P of some fact phi, and like the fact that P star is equal to argmax, like the UDT procedure. Like this is the same as just the probability of phi.
Okay, but I mean, my question here is, why can't we just skip from I think it'd be 4? Yeah, 4 straight to 6 here.
Yep. So that's
Just by restricted coordination.
So jumping straight from 4 to 6, you're saying like, why can't we just go well, we know that we're argmaxing, or like we're conditioning on the fact that we're argmaxing, but we already know that we're argmaxing by knowledge of decision procedure, and so we can just drop the whole thing right away, right?
Sort of. I mean, I think I'm probably making an even simpler argument here, which is by restricted coordination, we know that the only thing that should matter for our payoff on seeing
Oh,
is the action we take.
gotcha,
So
yeah.
why do we even have that second not summand, conjunct? There we go. Why do we have that second conjunct at all in 2?
So that would
ABM is not
be,
O.
that would be correct if restricted coordination didn't have the P wrapping around it.
Right. Okay, I see.
So yeah, that's an interesting point.
Oh, wait, we're still no. We're still inside expected value. Measure 0 sets don't matter.
Yes, but the first statement is not about argmaxing. The first state is just conditioning on M. P star equals to something.
Yes, but I'm saying after that, we don't really need to mess up. Like, we're not even using restricted coordination at broad enough scope. We could just be using it for the entirety of that prior. Or sorry, not the prior, the conditioning thing we're on.
No, because the restricted coordination is talking about the argmax action, and the second one is argmax in action. The first one is no.
I see.
Like,
I see.
if this P wasn't here,
right?
We're talking about the arg. Okay, sorry, it would be if the P wasn't here and if the argmaxes weren't here. Then
yeah. Okay, so we can't in fact just skip that. We do need to apply it to the thing that's getting argmaxed.
But
that makes sense.
But you do make a very interesting point, because it's like a kind of small modification of the assumptions we could just skip.
Wait a second, aren't backing up even more? Don't we already know that our UDT agents running whatever pi star this is have already taken this argmax action? Like, whatever action they're picking is the argmax over your observation action pairs. So we could just say that we could instead just pass to this is the expected value of this, where no, I don't quite see it. Never mind. But it seems like there's still actually an implicit argmax here that means we could just skip like half this proof. Maybe we don't actually have to.
There is an implicit argmax, but you are conditioning on the fact that this argmax is equals to something. In actuality, it equals to M of AM. But you are not just conditioning on the fact that you are argmaxing.
If that's the case, we can do something really silly then, which is go from this argmax. We know that by argmaxedness of pi star, that expected value of u given pi 0 equals M of AM is equal to the expected value of the argmax over A, u given pi star of O equals A. Because they're the same.
Sorry, I didn't quite follow. Can you repeat?
Oh, what I said was, if that's the case, then we could probably do something very funny here, which is because we know that the UDT agent pi star has already picked the argmax, then we know that expected value of u given pi star of O equals M of A sub M is actually just equal to expected value of u given pi star of O equals A. Or sorry, where we argmax over the A. There we go. Or do we not get to assume that here?
Yeah, that seems like basically what I want to do, but what's the, like, zooming out a bit on this proof, the basic idea I'm trying to convey here is that suppose that the agent strictly prefers some self-modifying action, that must be because the self-modification forces it to do something that it prefers to do, but we know that it's already, we know it's already argmaxing on every individual case,
Yes.
So it shouldn't need to force itself in that way. That's kind of what we're trying to do here, right? So
Yeah.
how
Yeah.
is how are you skipping steps in that?
So the form of the no coordination principle requires an argmax explicitly here.
Yeah.
What I'm saying is, okay, let's pull this implicit argmax out of step 4 here. We have pi star 0 equals m of am, but by assumption, we know that in that case, m of am equals argmax over a of pi star of o equals a.
It does indeed. It does indeed.
Okay.
It is the same. It is the same. It will be the same expected value.
Great. So pull that argmax out. We get to ignore the fact that we have only almost sure equality because we're taking an expected value to wrap around the whole thing. And then you can drop the second half of that conjunction because that's no longer relevant.
I'm not quite getting it. I would love to see you write up alternative versions of this proof.
Yeah.
Like both the thing you're thinking of, and it also feels like you're like thinking of a bunch of things. So if you end up creating more variations, that would be great.
I'm not thinking of any additional variations here. I'm just saying half of this proof, if we already know that m of am is the argmax action by assumption here.
I'm just saying it seems like you're in the right mindset to think of variations. That's all. Like you're thinking about it critically in the right way that you might also have more ideas. But yeah, I'm not quite getting it, so I would love to see it right up.
Okay.
Any other discussion on this proof?
This proof, although like in light of Paul's comment, the faith in argmax might not be used in the eventual version, but I still want to make sure that I understand this assumption, because I feel like I still didn't get it. So could you backtrack the slide to the assumption? Yeah, thanks. So why is it like greater than or equal to here? Like, is there any case you could imagine where it's strictly greater? Or
So
is it like
this is purely like, here's an easy generalization that I can take. Like, at some point, I think this was probably an equality in my notes, and then I was like, well, we don't need to assume the equality. Because of the direction of the proof, we only need to assume an inequality here.
okay? And why is this like non-trivial? What is the gist of this assumption? What does this actually assume? Yeah.
Imagine that I am playing chess, and I'm playing chess by like considering moves, and I have some heuristic estimate of their expected value when I consider them. This is saying like, what's my expected value before I consider moves, knowing only that I will argmax, but not knowing, like not having done the argmaxing yet. This is saying my expected value, given the general fact that I will argmax, must be at least as good as the best expected value that I will find while argmaxing. So it's not an inherently plausible statement. If we consider the version where it's the equal sign, it's like saying I already know the max value of an action that I will find, even though I do not know exactly what action that will be. Like, as I said earlier, we need the decision theory to not know what specific action it will take so that it can do the argmaxing, so that these conditional probabilities are well defined. And yet I'm demanding that the expectation on the general knowledge that you do argmax is at least as good as the best individual action. But it is like exactly what I need to make a proof of this kind go through, modulo Paul's comments. And it is like, the thing I like about it is that it is it's reasoning about a decision procedure. So it's like a self-trust argument that follows from mathematical details of the decision procedure. The agent cares that it is an argmax that it's doing. Yeah, does that?
So trust
have
of the
any other
decision procedure, if I try to unpack this, it's like decision procedure is the argmaxing.
Right.
So trust in the decision procedure would be like, I know I'm argmaxing. And so I okay, let me just quickly finish.
Yeah.
So I know, so I believe like I believe that when I know I'm argmaxing, I will perform by like I will
Trying to keep
perform
this whole thing in
like
frame.
maximally.
Take it. Yeah, makes sense. I'll put it in the Discord, in the public channel.
Sounds good.
That's not the full proof, but it's like it's the main step, and after that, you should be able to see what I'm talking about.
Yeah.
We aren't over time.
Extremely.
I mean, yeah, we're running up on what I consider overtime given our current policy. I'll just open it up here when you put it in the Discord.
Oh, this is
For me,
sideways. Apologies.
today it's okay. Yeah.
Oh.
It's going to be
Yeah.
sideways. Sorry, 1 second. Let me take a better picture.
You're talking about Bayesian logical inductor? What? Or is this the screen from it is the other node?
There we go.
Okay. So it's just this part, yeah.
Yeah, I mean,
Wait.
The simple case just generally I've written up at the top there. And then there's a more complicated case, which is truer to the actual proof that I've written on the bottom.
Wait, you have a type error.
Okay,
On the left,
where?
you have a real number. On the right, you have an action. In the first line. Like the line with expected something equals to argmax something.
I think that's supposed to be the other way around.
What do you mean?
Or
Like
what is
it's still the real number equals to some action.
Should that in fact just be the max over A then?
I guess.
So I agree that argmax is an action and the other one is a move. I'm just trying to figure out why.
And the second line is also making the same mistake.
No, yeah, the second line is identical that way. Analogical that way. Let me
I
this.
like
And why? What's coming out of this then? Expected value of this, less than that.
I
Argmax.
suggest you to like written it out and like proof check it. Like
Yes. No, this is not correct as written. I'm just trying to figure out what how to write this down correctly. Argmax over that is this.
So the way to justify it by saying that we're using UDT is that the M of AM
Is equal to the argmax instead, right? That still doesn't give me argmax.
Okay, I think seem to get it. This uses faith in argmax, right? Like to get from the fact that we're using UDT to what you've written. This is exactly what the faith in argmax assumption is doing, according to my current understanding. Like,
yes, and that's a bad sign because I thought I was using restricted coordination.
I don't know. I have to think.
Yeah, I don't think this works. Never mind.
Okay. Well,
I don't know if this works.
It's very interesting, like how these assumptions are.
Yeah, I think you should
Yeah.
just if I understand what you're trying to do correctly, what you want to do is to written out the whole proof by Abram, like the original proof, and then try to replace M of A instead of in the line number 4 inside of the expectation. You need to replace P star of O equals to M of AM. You need to replace P star by argmax. And this is this is the thing.
Yes.
This is what you're trying to do. So it's like P star of O equals to argmax. And this is the assumption. And I guess this is what you're trying to do. But I don't think it will get you
Yeah, I don't think
anywhere.
it works,
Like
though.
this is my intuition. But okay, it's worth trying. It's worth to try.
yeah.
No, I think you're right. This doesn't actually work out as stated because if I want an argmax on the outside at all, I need moves on both sides. Yeah, I would need a move. Or wait. I'd want
You
that.
need to face in argmax.
I guess my major issue is that I don't really have a way to connect up argmaxes that would naturally appear inside the expected value to the fact that pi star itself is coming from some argmaxing process.
So what you're trying to say is that faces in argmax is kind of knowing the decision procedure. This is like close, but it's not actually true. If Abram, please scroll to the assumptions slide. Yeah. So this is because we have this phi. Like inside the argmaxing procedure, conditioning on anything else besides the policy points is not the decision procedure you actually do. It's something else. It's some other argmaxing. So it's something more and beyond than agent knows its own decision procedure.
Okay. I think I see why it is we need to use faith in argmax here then.
Why do you figure it out?
What's up?
I'm glad we figured it out.
Oh, yes.
I think like perhaps a good thing to do, but I'm not sure if I'm able to do it. Based on my current understanding, is that everybody writes out their own version of this proof with their maybe like own assumptions and the proof. If we're able to, and we could just compare it. I think that would be very very helpful, like an inspection of what we're doing today.
Yeah, to me that would be great. I think this proof does have a lot of like questionable decisions. It isn't as simple as the other proofs. It can be elaborated in different ways than the way that I've done it. And yeah, maybe we'll come up with a better version that way, or maybe it'll just help you guys to understand the space of possibilities better. I agree that would be a good exercise for everybody to try.
Do you think that it would be helpful for us to read what maybe Linda wrote during her internship? Is that like
Yeah.
tightly related?
Okay, so I could prioritize typing up those notes. So, like, yeah, like I've got this whole book of notes that I haven't sent you guys that are like my notes from that time period, which are like very different from what we've been talking about because things have like developed, but there are some ideas in here that are like potentially interesting. Yeah, the actual proof that Linda wrote up is significantly different from this one. There were other things that I wanted to do this afternoon, but maybe in the near future, I will prioritize writing up some of these notes for you guys. Okay, so just to get to my commentary slide on this, like you guys have raised a number of issues. I'm saying like, yeah, it's at least Vingian. It at least comes from reasoning about the decision procedure instead of like the coordination assumption proving basically everything for you. Like it's this plausible way of reasoning where we're like, oh, should I self-modify? Well, I know that my future self already picks an optimal action, so I don't have to, right? Like this is good. The reasoning itself is kind of rough and weird. It's not clear how much sense it does make for an agent. Like I've just assumed the agent is reasoning about itself in this way, but it's not really clear that it makes sense. In particular, the faith and argmax assumption is my least favorite assumption here. Like it's quite critical to the reasoning, but it is basically assuming omniscience about how good things can be. We know that this best chess move is out there, even though we haven't looked at all the moves yet. And so that feels kind of implausible. And then this is more like a narrative like how I'm transitioning to the next part of the talk, but it's like, so the kind of the crux is how to reason in these situations of logical uncertainty. Updateless decision theory fundamentally is a logically uncertain decision procedure because it's supposed to know its own decision procedure, but not yet know what specific actions it takes so that it can consider these conditional expected values. But I haven't, so far in these slides, been reasoning using a real theory of logical uncertainty. I've just been using probabilities and expectations as if they make sense without like a significant theory of like, first of all, the self-referential issues when we're talking about nesting statements of probability or expectation inside of other statements of probability or expectation, which is problematic in general. And then second of all, this idea of not knowing the consequences of computations yet is like something that I haven't invoked a normative theory about how we should do that. And faith in argmax in particular raises questions. And so then the rest of this talk is going to be about those issues.
I hope you guys don't find this off topic, but I have a specific comment to make about the chess analogy because I really like playing chess, and I see a specific difference when computational uncertainty is factored in, what specifically for chess, like for especially for human players, but I believe for machines as well. Like we strategize so that we don't get into situations where finding the best move is very difficult. So this is like I have faith. Like this is like a how faith a failure mode of faith in Rmax when you're not logically omniscient. Like
Yeah.
I know, like I will try my best to find the best move at that point, but I still have to factor in, like, don't get into a situation where finding the best move.
Look, here you're talking about utilities of the computation. Here we are assuming that way. We are not talking about it. We are thinking about like like how much we think is not like an issue. Am I having troubles with connection?
I hear you fine.
Yeah, me too. But
Okay.
I don't understand why you're saying this. Isn't computational uncertainty exactly like like about no? You're saying I'm assuming there's a cost to computation. Are you saying that? Or what is utility of computation?
Yes. You're assuming cost of computation, and you are calculating like the costs of computation in different scenarios. Like this is what is happening inside your mind, I assume. And this is not what we're here doing. Like this is a problem, but I already raised this question with Abram, like on personal meeting, like about what about if we try to calculate the expected utility of calculation of, for example, expected utility.
Sorry for cutting out, but I think it's not the same thing.
Not the same.
With
Okay.
what I had in mind. So I maybe my problem could be mapped with your issue in some way. But what I'm thinking now is like trying my best to find the best move. This itself doesn't have the same power in different situations, because you are not logically omniscient, and there are hard situations and there are simple situations. So
Yeah,
I think that this factors into trust, in the sense that if you know that your power to find the best move or policy point is limited, and you still allow yourself to get into a situation where you doing your best will behave poorly, then you shouldn't trust yourself. So I think there has, in the case of like logical non-omniscient agent, it seems that you need to have some assumption that says, or something built into the decision procedures that says that I trust myself to not to try my best to not get into situations that are too difficult for me. Does that make sense?
There's something here that's quite interesting to me. I don't think it's exactly what you're interested in necessarily, Norman, but I feel I see the connection that Roman is pointing at, and I don't want to like what Roman is pointing at is that I don't want to change from argmax to some bounded time search algorithm or something like that, because that feels to me like it introduces a bunch of arbitrariness and complexity. And so, or like again, considering chess, it's like chess algorithms, they don't just argmax over what the best expected value for individual actions are. They do the tree search, right? They look further ahead. And so we could consider things like that. Norman isn't proposing that, and Roman isn't proposing that, but like we could consider things like that, but it introduces this complexity that feels much more arbitrary to specific intelligences and specific algorithms, as opposed to the generality of thinking about probabilities and expectations that seem like very broad rationality concepts.
And
But
more
nonetheless, I'm sorry, like I'm like the reasoning here, the reason that I need to make this implausible faith in argmax assumption is essentially because I just have to be like, that's my way of trying to instantiate this idea that we know that our future selves are doing their best, and so we expect our future selves doing our best in abstract to be at least as good as us now doing our best to pre-solve that problem and constrain the future self to the best action that we can see, right? So because my future self can do the full argmax over any self-modifications that we're able to impose, then I need this like full faith in argmax assumption, but it feels implausible. But it also feels implausible that my future self now, like speaking in practical terms, not abstract decision theoretic terms, I have more on my mind right now because I'm dealing with the situation that I'm in addition to thinking about this future situation. And the future self just has to think about this future situation. And so the practical reason why I trust myself has to do with cognitive capacity, that I'm like more burdened now if I try to restrict my future actions. And in the moment, I can remember the thoughts that I had, and I also can think further thoughts. And so it does feel to me like writing a better proof than this one that I've written involves thinking about the like bounded amount of computation that we have and these kind of practical issues of cognition. But I want to find a way to do that without introducing too many arbitrary specifics about like what algorithm is involved. I want to do that in a way that like still tries to approach rationality in these fairly general ways. So I think there's a lot of food for thought here.
Responding to the last part, Bayesian logical inductor trusts its future self. So that might be by design, and you designed it that way because of that. Like you try to replace face and argmax, right?
Yeah, I mean, Sam designed it that way, and
yes,
he wasn't thinking about this specifically, but of course that's why I've latched onto it so hard here for this research program.
Okay.
Because it seems very relevant to me.
The one thing I wanted to point out is that like this tree searching thingy is actively contradicting the assumption, the restricted coordination assumption and just coordination assumption. Like this is like you are actively saying that your action depends on what you are choosing next. What is the next policy? And this is what we assume in a way in the coordination.
Yeah,
also,
that's right.
Can I also, like in the draft paper, how much time do we have? Sorry, we're really over time. I'm not.
So Norman is the constraint.
Yeah.
I'm not constrained this week because I prefer to be an interviewer too. Like
okay.
This week, so, yeah.
This is like a little bit off topic. This is just a thing I noticed in the paper. You saying about counterfactual mugging version something, version A, version B, something like that. Yes.
The empirical.
And I assume that if you're using UDT 1.0, they're going to be the same. Like they're going to be introduced new coordination problems, because you need in the first counterfactual mugging you are not actually cooperating with anyone. You in the other scenario, like if the coin lands other way, Omega just gives you money and you do not need to take any action. But in the when there is multiple coins, when there is a spectrum of coins, then you need to have a good prior on what you are going to do when you are faced with another coin.
Yeah, that seems right.
You already knew that, right? I just
I wasn't thinking about that. I haven't
Okay.
thought through the implications of that.
okay.
I think it's maybe not something I want to include in the paper in terms of like it isn't super relevant to the point that I'm trying to make with that decision problem in the paper, but it does seem like a relevant thing to think through for the decision problem.
It just that, like, I think that this, like, you're assuming that it's UDT 1.0 that's taking this, like, you are making this claim about, like, this is doing the right thing in this scenario and also in this scenario. Like, you are talking about 1.0, like, right?
Maybe I should talk about 1.1 there.
Yeah, because, yeah, otherwise it's just not true from my perspective.
Sorry, I will need to go.
Okay, okay.
I should
Okay,
probably
bye.
head out as well.
Bye.
All right. Bye. Yeah, thanks everyone. I really appreciate it. It's
Yeah,
been very
good. Yeah, thank you. Goodbye.